hi there. This is a prototype of the RoamIO tracked unit, and what we did here is set up an auxiliary computer so we can give all access to the Geonics system, which takes measurements. And the auxiliary computer gets GNSS data from the unit. It also gets internet connection, so you can remotely log into the computer and automate all your measurement needs.
And can you point to the auxiliary
Absolutely.
computer?
This is the auxiliary computer, securely taped up for now. Eventually it'll be in a nicer box. Yes, and this is the dual antenna system from which we give high precision GNSS coordinates to the unit. Yeah. Right now it's receiving the data through Bluetooth. You can also go for wired, but we believe Bluetooth has less distortion.
Excellent, thank you for that. And now we'll show you how the software works.
Yeah.
Okay.
Hi. So as explained previously, we have an auxiliary computer set up on the robot on which our software and the tablet works, and the tablet itself has apps that can run the navigation for the robot and the application of Geonics itself together. So I'll show you. The tablet has pre-installed applications of Geonics, which actually helps connecting the instrument and the robot. We have the Bluetooth, so basically there are two connections that are needed. One is the GPS and the second is Bluetooth. GPS is needed to map the whole land where electronics and the soil properties change, and Bluetooth is needed to log the data from the instrument. So the Bluetooth is already connected with the instrument and the tablet, on which that is the auxiliary computer, and it's logging all the data from the instrument to directly the auxiliary computer that is set up on the robot. And we do not need any extra instrumentation and setup cost for GPS, because we already have our GPS set up on the robot and we are using that itself, that is directly wired and linked to the auxiliary computer. So and the app, I can show you how to connect the Bluetooth. It's very simple. It's the computer directly works on Windows 10, and so it is very straightforward. You just go to device manager and Bluetooth, and you can connect Bluetooth. Here you can see the Bluetooth settings, and the EM38 MK2 is paired with the tablet, that is the auxiliary computer, and it is ready to log the data. Now I'll show you how to connect the software. So here's the software. This is the Geonics software that helps logging the data from the instrument. And actually the software is pretty easy, and you just need essentially two COM ports to know, and that needs to be connected, which is similar to what similarly it could be set up as it could be set up on other devices. It's nothing new for our robot. And the GPS, you can see the GPS. One second. Over here you can directly go on logging, and the software is ready to log data. You can see the conductivity is changing here, and that shows that it is ready to, and I just need to click on data file. So this data file that you are seeing here is directly getting loaded and saved on our auxiliary computer. So, and you can actually access that file remotely as well, as I am doing it right now. So you do not need to go to the robot or need to plug in the computer or anything. And not only this, but I can minimize and show you that we also have another software already set up where you can this is another software of Geonics that they provide, and this software actually helps converting the M files to N files to M files, that is converting the raw GPS and data files to the geographic files, where you can actually visualize what's the soil properties and conductivity of the land. So yeah, we have both the softwares, and this has a gray screen essentially. It will have data when you load the file here. So Yeah, as I can show you, the file is already saved here on the computer, and you can see as I go to the computer, inside the documents I have the folder EM38 MK2, which has a test files, and all these are the test files. These are the files that I'm talking about, M file and the N file. So this is a conversion that is done using the DAT software. And yeah, as you can see, it's pretty simple, and everything comes loaded into the same tablet. Our navigation, how to load the map for logging the data for the whole farm, as well as how to log and connect it with the instrument. Everything is set up in this, and we don't need any extra software or setup or any other computer. Yeah, thank you.
Excellent, excellent. So what you've said is that essentially a customer that is already used to using the Geonics
Yeah,
software
it's the same
on
for
they don't really need anything different. If they already, whatever they've currently been doing to collect data using the Geonics software, they'll be able to continue doing.
Yeah.
And it will be sent remotely. You can run that software remotely on your tablet. And your tablet is also running the navigational software and showing you in real time your
Right.
survey status as you're collecting data.
Yeah.
Okay.
Certainly, and we have even made one step easier for the users by directly, connecting with the GPS, because when we were trying and testing it for our robot, we had another GPS module that was mounted on the instrument or somewhere else. That would actually increase the cost of the instrument, because we will have to buy another GPS or set it up on the instrument, which may actually have some changes on the reading. But right now we are just essentially using our double antenna GPS, which is even more precise. So I think easier and precise for the instrument.
Excellent. And so in a short couple of minutes now, we're going to start collecting data, and
Yeah.
we'll continue. Let's get a good look at the sensor.
So this is the Geonics software we can see right now. So we're receiving our NMEA strings or GPS coordinates. And then from here we can go and press to go and log the data. So we can start logging data on the computer that's on board. And then from here we go to the multitasking, and then we can go to our RoamIO app. And then here's where we actually gonna start running our autonomous navigation so that we can do the soil analysis autonomously. So here we're gonna go ahead and we're gonna start our navigation. So the robot lets us know that it's about to start the navigation, and then here we can see the map where it's gonna start going through this entire path. And we can see there how the soil sensor is being pulled. And here we can see we're reaching the end point of the first segment. So now what the robot's gonna do is it notices that it reached the end point, and now it's gonna go and connect to the second segment of the total path. Yeah, we're gonna get a little bit. So there we finished the connecting segment, which is the second path. And then we're actually gonna start the third path now. Yeah, and here you can see how it's about to do the last turn there, and it's gonna go to the end point, and that's where the navigation ends. There we go. All right, so once we're done the navigation, let's say we just want to put it back in a truck or something, and we just want to manually bring it back. Then what we can just do is we can take over the RC, and this always supersedes whatever commands are being sent by the onboard computer. That's a safety feature too. So here we can just turn on the RC, and then we start bringing it back. And this has a really good range. We should get at least 50 meters from the RC. And this is very useful just to bring it back, and where you're moving it like inside a truck, for example, outside a truck and so forth. So it's pretty handy, and it's also a safety feature. And that's it.